Hello everyone, welcome to the presentation from Group 13 with myself, Preeti, Rushabh and Niket. I will be starting with the first vulnerability discussion. The first vulnerability is CV 2021-4034. It was reported in November 2021 and recognized in January 2022. It affected all Unix-based OS such as Ubuntu, Debian, Fedora, CentOS, etc. The vulnerability is found as local privilege escalation of Polkit, formerly also known as Policy Toolkit, having a PKExec service. So what is local privilege escalation? It is a type of network attack to gain unauthorized access within a secure environment. It happens when one user acquires the system rights of another user and gains access to a confidential information. This vulnerability can be exploited locally only and not remotely by the intruder. It is a vertical privilege escalation, meaning an attacker attempts to gain more permission or access with an existing account they have compromised. For example, an attacker takes over a regular user account on a network and attempts to gain administrative permissions or root access. How does the vulnerability work? Polkit, formerly known as Policy Toolkit, controls system-wide privileges in Linux, Ubuntu, Kali, etc. OS. pkexec is an execution utility of this package that allows an authorized user to execute a piece of code as another user. For example, pseudocode command. By default, if a user is not specified, the executed code will be run as root. This utility is installed in all of Unix-like OS by default, and the vulnerability was embedded since its creation in 2009. The vulnerable code is in C language and main function with three arguments. argv is the array of string and its elements are the command line argument passed to the program when it was executed. argc is an integer that represents the size of argv. envp is the argument that provides the function with access to the program's environmental variable such as path variable. pkexec has a syntax that includes the command line pkexec and the arguments such as username and other program arguments. On the slide, we here have a snippet of the main function of Polkit, and the first for loop, which is seen at line 534, includes the argc value. Just imagine if the value of argc is equal to 1, that means this for loop will exit giving the argv1 value within the path, which is then finally written to gfind program in path file. In the memory address, all the arguments are stored one after the other, just like the stack. argv followed by argc followed by envp. In order to exploit, we will store envp0 as exploit, envp1 as path is equal to gconv underscore path, and envp2 as null. Next, we need to create a directory as envp1. Under this directory, an exploit file named exploit is created to execute a shell with root privileges. Finally, the command will be read as on the screen. It will ask the OS to run the exploit file from the path that we have provided, gcov underscore path, meaning it will execute the file exploit stored within the new directory we created. Additionally, to avoid any further validation checks, the char set and the shell value are changed to other values which are not acceptable. We have set these values specifically because the code will follow a path leading to run the malicious hidden code. So, from the start, code will proceed with validating the environmental variables we supplied one by one until it gets to one located in envp2. The path given as the shell path will be validated against the special case, and since it does not meet the conditions as we have given the wrong value, it will print the error using the service gprinter. Gprinter will check for the charset environmental variable, which will populate with the value of not UTF-8. Since it is not UTF-8 encoding, it will call iconvopen to help convert the encoding of the error message iconv open will refer to the conversion file located in gconv underscore path environmental variable, hence running the exploit file giving user root privileges. This slide shows the snippet of the code which is used to do all that we have just discussed in the last two slides. Impact of such a vulnerability. CV 2021-4034 has the power to allow even unprivileged user to gain root access to a wide range of systems and gain administrative powers. It is a threat to confidential data for the organizations. It is very simple to exploit this vulnerability. All that is needed is a user who has access to the system and their privileges can be escalated. It affects all Unix-like OS. One way to mitigate this vulnerability without updating would be to remove the setuid permissions with the command chmod 0755 which pkexec. Apart from this, changes have been made within the main function of polkit. In this screenshot within the slide, we can see that an additional if loop is written to check argc value when less than 1 to exit the program. Another loop for gprinter is used to avoid running any shell commands. The line where argv value is assigned as path without any checks is removed. And finally, another if loop is written to check the value of argv not being equal to null. Only then the value of the path is assigned.
Hello everyone, myself Rushabh Khara. I'll be talking about CVE 2019-0232. So basically it's an RCE vulnerability and the software which that vulnerability was discovered is Apache Tomcat. So what is RCE? We'll see a bit about RCE, that is remote code execution. So the RCE is a class of software vulnerabilities. RCE allows a malicious actor to execute any code of their choice on a remote machine over LAN, WAN, or Internet. RCE belongs to the broader class of arbitrary code execution, that is ACE. With the Internet becoming more and more advanced, RCE vulnerabilities impact grows rapidly. RCEs are now probably the most kind of arbitrary code execution vulnerabilities. The impacts of RCE are the malicious actor can add, read, modify, or delete files. They can change access privileges. They can turn on or off configuration and services, and they can communicate to the other servers as well. So, what is CVE 2019-0232? So, in the 2019, a flaw was discovered in Apache Tomcat, where a Java runtime environment can pass a command line argument in the Windows operating system. The execution of arbitrary commands via Tomcat's Common Gateway Interface (CGI servlet) allows an attacker to perform a remote code execution. So basically, this vulnerability is in CGI servlet that is only on the Windows where there is a non-default configuration in conjunctions with batch files. When running on with the CLA command line argument enabled, the CGI servlet in Apache Tomcat is vulnerable to RCE due to bug in the JRE passes CLA command line arguments to Windows. This vulnerability is specific to the Windows platform's treatment of file names and how they must be quoted. A Tomcat running on Linux host is not affected, as I said earlier. Uh, this issue is only on Tomcat CGI servlet class. According to the Apache Tomcat CGI servlet description, it's disabled by default on in all the versions. as of now. The new versions have the CGI servlet as disabled. The affected versions are Apache Tomcat 9.0.0 M1 to 9.0.17, Apache Tomcat 8.5.0 to 8.5.39, Apache Tomcat 7.0.0 to 7.0.93. So we'll see the how the affected versions vulnerability look like. So in the affected versions, the conf or the context.xml file have this context privilege as true, uh, and the command line arguments were also the true. So this softwares are vulnerable if the command lines arguments are true. Here we can see that the code is not properly sanitized, so the attackers can get into our systems through the CGI servlet. We'll see the mitigations. So the fix was simple. They have used a regex pattern, which basically make sure that if the JRE, that is Java Runtime Environment Platform, is Windows, then the command line argument gets sanitized properly. Match this. They match this pattern, and the execution won't happen. So the another mitigation is disable the CGI support. So in the newer versions, it's basically by default it's disabled. The another mitigation is users should set the CGI servlet initialization parameter, that is enable command line arguments to false to prevent possible exploitation of CVE 2019-023.
Hello, Niket here. Today's presentation topic is CVE 2022-24123. Its description is potential remote code execution, that is RCE, via cross-site scripting XSS payload. The vulnerability types are XSS and RCE. Now, what is the impact of these vulnerabilities? Captures users' cookies and session ID, inject Trojan functionalities into websites, modify files on the host, account takeover, change access privileges, leaking sensitive information like login credentials, execute arbitrary code on a remote device. Now, brief description of the CVE. Mic test through 0.16.3 doesn't sanitize the input of a mermaid block before rendering. This could lead to a remote code execution via .md file containing a mutation of cross-site scripting payload. The CVSS core for the version 2 was 6.8 and the latest CVSS core is 9, so it's a critical vulnerability. And which versions are affected? The versions affected were up to the 0.16.3. And let me tell you about MarkText. What is MarkText? MarkText is a open source markdown text editor, and the Mermaid is the JavaScript based tools that allows us to create and modify the diagrams and charts dynamically from the markdown text definitions. Now, brief introduction of XSS. So XSS attacks are a type of injection in which malicious scripts are injected into otherwise benign and trusted websites. XSS occurs due to an attacker who uses a web application to send malicious codes, generally in the form of browser-side script, to different end users. And these type of flows are quite widespread, and they can occur because the client doesn't know that what is going to be executed, and that generates without validating or encoding it. What are the types of XSS? The refracted, the stored, and the DOM based. I won't go into the much depth of this. Mitigation. What can we do to mitigate the XSS attacks? First one is output encoding. HTML input sanitization, safe syncs, cookie attributes, content security policy, web application firewalls. Now I won't go much. I won't cover the RC vulnerability as Rusab has discussed. The expert section. Here you can see uh, the author or the attacker is trying to create a sequence diagram. B and S are the actors, and B is trying to send a message to S. But instead of typing a message, he or she is sending the vulnerable code that is going to execute on a client. And it happened because the code wasn't sanitized before being rendered. And the affected version of the Mac test was 0.16.3 and it was tested on Mac OS 12.1. Now, how to mitigate those? Basically, they're gonna change the versions and sanitize the code. So here you can see they have changed the versions of Mermaid. Now here in the index.js you can see they have imported the class and the sanitize function, and in the below you can see they have used the sanitize function. So sanitize will basically filter the backslash, forward slash, and remove those from the actual input. Here you can see the sanitization, and they have added the security level strict. Here they have used the FS promises, and here they have used the sanitization function and use the regex to match those. There's also a DOM purify.js which will basically purify the inputs and allows us to uh, accept the type of traffic. Here also it's a sanitization. These are the references that we have used. Thank you. That's it from our side.